Okay, for number one, graph of y equals x squared minus 5. We're going through the 2.1 to 2.3 quiz study guide here. We're graphing x squared minus 5. That's a parabola we can see because x is squared and y isn't. The technique I gave you in chapters 2.1, 2.2 when we did this, before we got to 2.4, was basically the vertex formula we've been doing in chapter 2.4. So my x-coordinate of my vertex is going to be negative b over 2a. And b is equal to 0 because you can see there's no x term. So officially y equals x squared plus 0x minus 5. If you stuck an x term in, it would be a 0x. So b's value is 0. So the x-coordinate of my vertex here is just 0. So that tells me if I'm going to use a chart here, x and y, I want x equals 0 to show up in my chart. And I would probably pick numbers near 0. So I'd pick 1 and 2 and negative 1 and negative 2. And all I got to do to get y is stick them into this formula, and then that tells me what y equals. So if x is negative 2, negative 2 squared is equal to positive 4 minus 5 is equal to negative 1. If x equals negative 1, we put negative 1 there, we're going to get negative 1 squared is positive 1 minus 5 is negative 4. If x equals 0, we're going to get 0 squared is 0 minus 5 is negative 5. If x equals positive 1 squared is positive 1 minus 5 is negative 4 again. You notice the symmetry, they should be symmetrical about the vertex. That gives me a little bit of feeling of goodness there. And that tells me this is also going to be negative 1. If you try it out, 4 minus 5, negative 1, if x equals 2. So I get 5 points, negative 2, negative 1, negative 1, negative 4, 0, negative 5, 1, negative 4, 2, negative 1. I get that nice parabola shape that I'm expecting. And then the graph just continues on forever. Make sure you're putting those arrows to demonstrate it goes on forever. In this case, since it does. If it does have a stopping point, such as a square root function or something like that, then just put a closed circle to represent that stopping point. This graph has no stopping point, so it goes on forever. We put the arrows. Number 2, find the equation of a circle with a center of 3, 1 and passes through 6, 5. 6, 5 is on the circle itself, so if I'm imagining a picture of this, you don't have to graph it, but if 3, 1's about here and 6, 5 is about here, my circle's looking kind of like that. Here's 6, 5. Here's 3, 1. The distance between those two numbers is the radius. That's the other thing I need to know. So you can see on this problem here, they're giving me 2 of the 3 numbers I need to write the equation of the circle. I need to determine the radius based on what they're giving me for points. So what I would do on this problem, once I see it's that type of problem, is I would say my radius is equal to the distance between center and point on circle. So I would create my distance formula structure here. What goes in this parentheses is the distance between the x values. From 3 to 6 is 3 spaces. What goes in the other one is the distance between the y values. The distance from 1 to 5 is 4 spaces. And if I work that out, I'm going to get the square root of 25, 9 plus 16, which gives me a radius of 5. So once I know what h and k and r values are, my equation of a circle is x minus h squared plus y minus k squared is equal to r squared. That's your structure. That's what your answer needs to look like. H and k and r are going to be replaced with the numbers h, k, and r. And notice it says minus h and minus k, which means that whatever h and k are, we're subtracting them. So I'm going to get x minus 3 squared plus y minus 1 squared is equal to 5 squared. I do want you to square the radius. Even if this came out to square root of 7, the square root of 7 squared is 7. So we should be able to get a nice pretty number off of here every time. Things that I've seen people do in the past wrong, they have the wrong signs on these things. Whatever signs are in the center's coordinates, these are the opposite signs. So if these numbers were negative, these numbers here would be positive. So they're always opposite sign because that's what minus means in the formula. People sometimes leave the squares off. That's a major issue because then you don't have a circle anymore. You leave one square off, you get a parabola. You leave two squares off, you get a line. So make sure the squares are there. The other thing people do sometimes, they'll leave the plus sign off. They'll just say this parentheses squared, that parentheses squared equals number without a plus sign. That's the structure, that's what has to be there. So I'm looking for correct signs here. There has to be a plus. I'm looking for squares. I'm looking for parentheses. I've seen people leave the parentheses off before. They'll write x minus 3 squared, no parentheses. And that's just wrong. So I'm looking for the parentheses. I'm looking for each group being right. Looking for the squares. I'm looking for the plus. And I'm looking for equals, whatever the radius is squared. This is the only real math you have to do in the problem. Evaluating the radius. So if you get the correct radius, that's going to be important to me. So make sure that you understand this. Make sure you know this structure. Hopefully you've had enough practice that you've got it pretty much memorized at this point. Number 3, find the center and radius of the graph of the circle with the equation of this. So this is kind of going backwards. The last one we knew the center and radius. We had to find the standard form. Now we want to use the standard form in order to find the center and radius. And as you can see, this is not in standard form. So first thing I want to do is, and again, my standard form is x minus h squared plus y minus k squared equals r squared. X's are together, Y's are together, numbers are on the other side. So the first thing I'm going to do in this problem, in this general form structure they gave me, is I'm going to rearrange it, rewrite it, so that I've got more along those lines. So x squared minus 8x are the x's. Leave a little space. Y squared plus 6y are the y's. Leave a little bit of space. Equals, and 11 is the number. Negative, move across, becomes positive. That's priority 1. Get the x's grouped together, get the y's grouped together, get the number on the other side. Anticipating this structure, that's what needs to happen. Next, we're going to complete the square. Magic number for x, half of 8 is 4, 4 squared is 16. Magic number for y, half of 6 is 3, 3 squared is 9. In all, I've added 16 and 9 to the left, so I have to add 16 and 9 to the right. We're working with an equation. In order to be an equation, to be equals, we have to add the same amount to both sides. The purpose of that is now I've got a perfect square trinomial. So I've got my perfect square trinomial here. I get my parentheses square that I'm looking for. The square root of x squared is x. The square root of 16 is 4. This is a minus sign, so I put a minus sign. Whatever's in front of x, that's what sign goes in there. Then I'm going to put a plus. And here's my y expression. Once again, a perfect square trinomial. So I'm expecting a perfect square, parentheses squared. The square root of y squared is y. The square root of 9 is 3. And the sign in front of 6y is positive, so I put plus. Equals, and then all this stuff adds up to 36. So just like that, in 2 pretty basic steps, rearrangement to complete the square to factoring, we get to this nice structure that we're looking for. My center is the opposite sign of these two numbers in that order. X first, y second. So I'm going to get positive 4 comma negative 3. My radius is the square root of this number. If that came out to 7, right, r equals the square root of 7. Leave it in square root form, that'll be fine. But that's it. So find center and radius of the graph of the circle. There you go, center and radius. Number 4, determine domain of f of x equals that. Now, domain, the 2 restrictions we dealt with in this class have been rational functions, division by 0 is not allowed. Radical functions, you can't take the square root of a negative number. Okay, this has both issues. We have division by x, we also have a radical. So, if I was just focusing on the radical alone, nothing else, I know that x minus 2 must be greater than or equal to 0. That's the radical rule. Whatever the radicand is, whatever's inside the radical, must be either greater than 0, which is positive, or equal to 0, because the square root of 0 is 0. Anything less than 0 is going to be the square root of a negative number, making it imaginary. So, once I've established that for the radical, now looking at the rational part of it, we're dividing by this. And as I've already said, the square root of 0 equals 0. Division by 0 is no good. So, where this is the radical rule, do that one first. Moving on to the rational rule, gets me to x minus 2 must only be greater than 0. Okay, so establish both rules. If there's an equals 0 allowed for this, you have to throw out the equals 0 for that. The greater than 0 stays alive. So this is not what we're doing. We're going to do this one instead. So start off with the radical rule and then adjust it for the rational rule, which again does not allow division by 0, so equals 0 is thrown out. At this point we solve x is greater than 2. That's my domain. Domain is the set of all x such that x is greater than 2. That's all that problem is. Ask for domain, there's the domain. Write in good set builder notation. If you just give me this, I'll give you, it's a 10-point question, I'll probably give you 8 points. Give me the set builder notation, you get the other 2 points. So make sure you write your answer like this. If you're trying to do set builder notation, do it incorrectly, I'll give you 1 of the 2 points for at least trying it. So give me the right answer, that's 8 points. Bad set builder notation gets you an extra point. Proper set builder notation gets you all 10 points. Number 5, graphing a piecewise function. J of x equals all 3 of these functions depending on x's value. So x's value establishes how I'm going to graph it. So I start off with piece 1. Anything less than 2 is going to get me an answer of 3. So I'm going to pick numbers less than 2, 0 and 1. And I'm also going to pick 2, even though I'm not supposed to because it doesn't say equals 2. But I'm going to pick 2. I'm going to break the rules here and be kind of drastic here. I'm going to put OC. OC meaning open circle, meaning that I know I'm not allowed to pick 2, but if I could pick 2, that's where it would be. So I'm going to put an open circle to represent it. I'm going to put closed circles at everywhere else. So this is where the open circle is happening. Nowhere else does it happen. And this is just a constant function. J of x equals 3. That means if x is less than 2, the answer is 3. 0 is less than 2, the answer is 3. 1 is less than 2, the answer is 3. And again, we're going to pretend 2 is less than 2, the answer is 3. Okay? That piece ends at the point 2, 3. The next piece begins somewhere else. So now the next region says x is between 2 and 3. This one does say equals, and it says equals. So it's actually allowed to equal 2 and 3. So I'm going to pick 2, I'm going to pick 3. I'm also going to pick 2.5. I always like to pick at least 3 numbers just to be safe. And if those 3 numbers give me a good enough look at the graph, that's fine. If not, I can pick 2.25, 2.75. I can pick more numbers. But again, anything between 2 and 3 is going to be using this function. Equals 2 equals 3, so these are both closed circles. And again, we're only worried about open and closed circle issues at the boundaries themselves. 2.5 in between is obviously going to be a closed circle. So this is telling me to get y, I'm going to square x, then subtract 4. 2 squared is 4, 4 minus 4 is 0. 2.5 squared is 6.25, minus 4 is 2.25. 3 squared is 9, minus 4 equals 5. Okay, so those 3 points happen on the second piece. And my final piece says if x is greater than 3, I'm supposed to use that function. So make a third chart. Again, it says greater than 3. I'm going to pretend it says greater than or equal to 3. 3 is my boundary. It does not say equals to. I've got to put an open circle at 3. And again, I'm pretending 3 belongs in here. J of x equals x minus 4. So to get j of x in this chart, we're going to subtract 4 from x. So 3 minus 4 is negative 1. 4 minus 4 is 0. 5 minus 4 is 1. So we create 3 charts for each function for each interval. And again, every x here is within this interval, so we're going to use that function. Each x here is within this interval, we're going to use that function. Each x in the blue is in that interval, we use that top function. So what's left to do is to plot our points. So 0, 3, 1, 3, 2, 3, open. As we can see, hopefully this is a horizontal line. Y equals number creates a horizontal line, so that's obvious, hopefully, to everybody. It goes on forever. Even though I only picked a 0, negative 1 is less than 2, negative 2 is less than 2, all these numbers less than 2. So going all the way to negative infinity, because x goes all the way to negative infinity, we're going to have this horizontal line. Starting at 2, 0, we're going to have a closed circle at 2, 0. 2.5, 2.25 would be about here, and 3, 5 would be about here. It almost looks like a straight line. I see x squared. I know it's supposed to be a parabola, so again, that'd be a situation. Maybe I want to pick a couple extra points. If I pick 2.25, and we're doing x squared minus 4, so 2.25 squared minus 4, and 2.75 squared minus 4, I get 2.25, 1.0625. and 2.75, 3.5625, 1, 2, 3.5625. Still kind of looks like a straight line. Just kind of give it a little bit of a bend so it looks like a parabola. It's kind of, as the parabola gets further away from the vertex, it kind of straightens out a little bit. And then finally, we've got our green piece. 3, -1 is our starting point. 1, 2, 3, -1, open circle. I've got 4, 0, closed circle, 5, 1, closed circle, and that makes this piece here. Notice the function is a linear function. Notice it's making a straight line. So again, each piece has its purpose. Each piece is graphed. Notice the red graph has no arrows on it because I started at 2, I ended at 3. That's closed circles. The blue graph has no arrow here because I ended at 2 with an open circle. The green graph started here with an open circle. The only arrows that should occur in a piecewise graph happen at the very end and the very beginning of the graph. Okay, it's going all the way to negative infinity, forever, arrow. It's going all the way to positive infinity, forever, arrow. It's starting here, no arrow. Okay, I've seen people try and put arrows in the middle of these piecewise graphs. You don't do that. So it starts here, it ends here. Those are endpoints, either closed circle endpoints or open circle endpoints, depending on the equals or not equals to in the inequalities. Expect a similar type of function, probably a constant, a quadratic, and a linear within the pieces. It's just a matter of which one's which and picking the numbers. I might make the quadratic piece a little bit bigger so you get a little more curvature to it. Might make it more interesting to look at. Number 6, an open box is to be made from a square piece of cardboard having dimensions 40 inches by 40 inches by cutting out squares of area, I should say area, x squared, from each corner. As shown in the figure, express the volume of the box as a function of x, and then state the domain of the volume, of v. All right, so we're going to create a v function in terms of x, x being how much we're folding up, and then we're going to state the domain of v. I will tell you it'll be exactly the same picture. I'm going to change. It might be a rectangular piece of cardboard. You're going to know these two numbers. So 40 inches and 40 inches. And what I left off my drawing was this. Okay, you're going to know these two dimensions. Those two dimensions are necessary to find out what you need to find out. So what I'm concerned with is to create this open box, this rectangular box, is what is the length and the width and the height. Okay? And the length and width come from the base, and the base is the bottom of the box. So if you can just visualize these four sides folding up, the bottom of the box is right there in the middle. The length is one of these dimensions, and the width is the other. It doesn't matter which one's which. In this case, they're exactly the same. From here to here, since that's 40, and we're taking x away from either side, this whole from here to here is 40, take x away, that gets me 40 minus 2x for this piece here. Similarly, this is x, and this is the piece we're concerned with. 40 inches all the way from here to here, we're taking 1x away, a second x away, so 40 minus 2x for that. And what we're folding up is x. So, the length is 40 minus 2x, the width is 40 minus 2x, and the height is x. In order to express the volume as a function of x, you simply need to establish length, width, and height in terms of x, which should be pretty simple to do from the picture. Volume equals length times width times height. And then we simply have to multiply that out. 40 times 40 is 1600 minus 80x minus 80x plus 4x squared. Now, what you have to be careful of is times x, right? Be careful that this product is all this stuff that's supposed to be multiplied by x. Make sure that we put parentheses around that entire product. The other thing to notice is 80x and 80x both negative add up to negative 160x. So now if I go ahead and distribute that x through, I personally like descending order, so I'm going to do x times 4x squared first, makes 4x cubed. X times negative 160x makes negative 160x squared. X times 1600 is 1600x. And just like that, I got my volume formula. And you can see the volume formula here is a polynomial function, and the rule of polynomial functions for domain is any number can be x. Okay, so for part B, state the domain of V, if I just saw the function, didn't know there was a picture attached to it, I would say all real numbers, but there is a picture attached to it. So to do part B, it's real simple. Your dimensions must be positive. So simply state that each dimension is positive. You simply have to solve those three inequalities. You're going to have x bigger than one number and less than one number is what you want. What you're going to end up getting is x bigger than one number and smaller than two numbers. And I'll show you how to handle that if these happen to be different. It doesn't happen here, but I'll show you how to handle it. So if we take either one of these, they're exactly the same, these two. So 40 minus 2x is greater than 0, which means negative 2x is greater than negative 40, which means x is less than 20. We divide both sides by negative 2, then inequality switches direction. This right here says x is greater than 0. That's already solved. X has to be greater than 0 and less than 20. And how we write that out altogether, 0 is less than x is less than 20. Not equal to. If x equals 0, we didn't make a box, we've got a square piece of cardboard. If x equals 20, we're going to have 4 pieces of cardboard because we won't have any space left at the base. So x has to be less than 20, has to be bigger than 0. So x is between 0 and 20. We always use less than in a compound inequality. That's my domain officially. Let me just remember that we do set builder notation. The domain equals the set of all x such that x is between 0 and 20. Alright, so we, again, use good set builder notation anytime you write me a domain. Now, for the chance that maybe these numbers are different, because maybe it's a little bit more interesting if that happens, let me just show you how to handle that. You're going to get 3 inequalities. One's going to say x is less than some number, let's say 24. The other one might say x is less than 12. The other one might say x is greater than 0. All 3 inequalities have to be true for a domain to be good. So if you get a problem, and let's say those are your results. These are both less thans, and this is a greater than. Greater than is already done. The less than is what you have to deal with. These have to be true at the same time. So if I pick a number, it's got to make this true and this true. If it doesn't make both of them true, it doesn't count. So if you just imagine trying to make this true, 23 does not make that true. If I pick a number 11 to make that true, 11 makes that true also. So when it comes to x is less than 2 numbers, x is less than the smaller number is the one that's going to work for both. Similarly, if you have x is bigger than 2 numbers, x bigger than the biggest number is going to be the one that makes both of them true. So if that were the case, we would go with 0 less than x less than 12. Domain equals the set of all x such that. So we write it out like that. So again, I might give you a rectangle instead of a square. That's the only slight difference in the 2 problems in the domain part of it. So you're going to have 3 inequalities to solve. One will already be solved like this, but the other 2 have to be solved. You'll get x less than big, x less than not as big. The x less than not as big is the one that counts. And again, small less than x less than big is how you write it. Write your domain in good set builder notation. Number 7. Find the equation of the line that passes through 3, 5 with a slope of negative 2. The only way I might make this different is this might be a fraction instead of an integer. You guys are in Trig, so deal with fractions if they show up. Equation of a line is what it has been since Algebra 1. Y equals mx plus b. That's x, that's y, that's m. So substitute those 3 numbers in to figure out b. So 5, which is y, equals m, which is negative 2 times x3 plus b. So 5 equals negative 6 plus b, making b equal to 11. Once I know the slope and the y-intercept, that's what I want to substitute to get my answer. So y equals negative 2x plus 11. That's not meant to be a difficult problem. If slope were a fraction, and this ends up being a fraction, just make sure you get a common denominator in order to be able to add and subtract those fractions that you get. Again, that's the only difference I might see to this, but I might even keep it an integer, who knows. But know how to do it with a fraction in case it shows up that way. Number 8, find the value of x in the domain of f of x equals 2x, or 2 plus x over 3, for which f of x equals 7. All this means, change that to a 7 and solve. Once again, this is Algebra 1 level, I'd say about less than 25. if you're not getting these, you're not trying hard enough. So f of x equals 7, change f of x to 7, solve the equation. Most of us don't like fractions very much, so multiply by 3 to get rid of it. 3 times 7, 21. 3 times 2, 6. 3 times x over 3x. The domain of this is all real numbers. 15 is a real number, so that tells me it's the right answer. So again, it'll be asked like that. It'll be some function like this. It'll probably be linear. I wouldn't throw a quadratic at you if the linear is on the study guide. So linear, just change f of x to the number, solve what you're looking at, get the answer, circle it, move on. Number 9, solve f sub 1x equals f sub 2x algebraically if that's true. F sub 1x, which is this stuff, equals f sub 2 of x, which is this stuff. Basically the same level of difficulty the last problem was. Trying to solve this, both of those things have a different expression to represent them. Set the expressions equal to each other, solve that algebra problem. Plus 14 goes here, minus 3x goes here. Negative 2 plus 14 is 12, 7x minus 3x is 4x. Divide by 4, you get x equals 3. Finally, number 10, determine the profit function, the revenue and cost functions given, determine the break-even point. Profit equals revenue minus cost. So, the profit function we're looking for is the revenue function minus the cost function. Notice the cost function is multiple pieces, so we put parentheses around it to represent that, so the subtraction distributes and hits every piece of the cost function. Leaving the parentheses off will cause wrong answers. I then want to simplify this as much as possible, so I'm going to get 92x minus 27x minus 61,880. Subtracting 97 and 20, or 92 and 27 gets me 65. So there's my profit function. I'll give you the revenue and cost function. You simply have to apply this idea correctly and simplify correctly to get the correct profit function. The second part of the problem asks us for a break-even point. Break-even's where profit equals 0. So all I'm asked to do, take my profit function, which is 65x minus 61,880, set it equal to 0, and figure out what value of x makes it equal 0. If x equaled 0, meaning I don't make anything, I end up with a profit of negative 61,880. That means I owe that much money. That's not good. So getting to a profit of 0 means that I don't owe any money, and after that, everything I make is going to be making money. So that's kind of what break-even is for. How many things do I have to make before I start making money? That's why we find this. So 65x equals 61,880. Divide by 65. That comes out to 952. And 952, it doesn't give us any type of thing, so maybe items. If it was more of a word problem, it might have talked about, we're making swing sets, and how many swing sets do we have to build before we break even, something like that. Or, 92x, we're selling things for $92, so whatever that would be. But anyway, keep that in mind. That's what the problem will look like. You should be able to handle that pretty easily. Linear stuff, it's not too challenging at this point.